So in this video we're gonna talk about ordinary differential equations, and more specifically we're gonna talk about linear differential equations. So for a linear differential equation, it's gonna have the general form of bx plus a0 y plus a1 y prime plus a2 y second derivative of y, and so on until we reach an for the nth derivative of y equal 0. So that's the general form of a linear differential equation. It is bx plus a0 y plus a1 y prime plus a2 y double prime until we reach the nth derivative. Now for the terms a0, a1, a2 and an, they are differentiable function that doesn't need to be linear. So a0, a1, a2 until an could be any differentiable function that not necessarily be linear. And bx is a function that doesn't depend on y, and we call bx the constant term. This we call it the constant term. Now, the highest order of the linear differential equation is equal to the highest derivative of that differential equation. So for example, if I give you y double prime, or the second derivative of y, plus y equals 0, this is a differential equation of order 2, which is the highest derivative here is the second derivative of y, so the differential equation is of order 2. Now there is an important thing here. If bx, which is the constant term here in the differential equation, if bx is equal to 0, then the differential equation is called homogeneous differential equation. Homogeneous differential equation. So if bx, the constant term, is equal to 0, then we call the differential equation a homogeneous differential equation. So if we look to our simple example right here, then I can tell this is a differential equation and it is linear, because here we have here the terms a, which is 1 here, and here is 1, and so I can say that a2 is equal to 1 and a0 is equal to 1, and I have here also here the constant term bx is equal to 0, and so this is a differential equation of order 2 and it is homogeneous. So this is a differential equation of order 2 and it is a homogeneous differential equation. Now, just to re-emphasize what I said before, so a linear differential equation has this general form: bx plus a0y until we have an for the nth derivative of y equals 0. The a0, a1, a2 until an are differentiable functions, and it's not necessary to be linear for these functions. And we said that if bx is equal to 0, then the linear differential equation is called the homogeneous differential equation, and bx, as we said before, is called the constant term. That's really an important introduction and some definitions necessary for understanding linear differential equations. Thank you.